Okay, so these are some of the problems on your lab. It says if your mass is 68 kilograms, how much work is done when you walk up a flight of stairs that's 2.9 meters high? It's the same thing you did in your lab, but in the lab we measured our weight, and the weight is a force. This right here is not a weight, it's a mass. So I would say that's a mass. Okay, if work equals force times distance, we need to have a force, and this is not a force, it's a mass. But we can calculate a force from this mass, and the force that we're using to walk up the stairs, we are having to counteract the force of our weight. So that's the force that we're exerting. And if you remember that our weight, the force of our weight, equals mass times gravity. So all we have to do is take a mass of 68 times gravity, which is 9.8, multiply those two, and you should come out with a weight of 664, back that up, 666.4 newtons. Okay, so that's your weight. And then we can plug this over here into this force, but I'll move it over here. So work equals force times distance, so we want to find the work done, and that equals 666.4 times the distance, which is 2.9. Alright, and if you calculate those two out, you should come out with a work of 1933 joules. That's what you should get here. And if you wanted to change that to kilojoules, you could do that, and that would be about 1.9 kilojoules. Okay, let's work on this problem. How much power are you generating if you get up the stairs in 2.3 seconds? All right, now we're looking for power and not work. We've just found the work right here. That's our work. And remember that our equation for power equals work divided by time. They gave us a time. It's right here, 2.3 seconds. So all we do is take our work, 1933 joules, and divide it by the amount of time it took to get up the stairs, and that's 2.3 seconds. I'll write a SCC here so you know that's seconds. So 1933 divided by 2.3, and you should come out with a power of about 840 watts. Alright, let's go to number 9. You have a backpack. It's full of books. The book's total mass is 24 kilograms. And you want to know the work it takes to raise it from the ground up to your shoulder. And we're going to call this distance about 1.7 meters. Alright, so for this one, once again, we have a mass. This is not the force. So we have to do the same thing that we did up here at the top where we had our mass. We've got to use the mass to come up with the force, and that force will be the weight. So here we go. Weight equals mass times gravity. So that would be 24 times 9.8. And you should come out with a force there of about 235 newtons. Alright, so that's your weight, that's the force. So then you do, sorry about that, that's work that we want to do. Work equals force times distance. We just got the force right here, 235 newtons. We'll put that in. So it is 235 times the distance. Our distance is 1.7 times 1.7. And if you calculate that, you should come out with about 400 joules. Make sure you can read this. 400 joules right there. Okay, and then if we want to calculate the power it takes to raise the backpack in 1.7 seconds, now we have a time component. We just calculated our work up here at the top, and that work was 400 joules. So we're going to come down here and calculate power. Power, work divided by time. So we'll throw 400 in here for the work. We just calculated that. Divided by this time, 1.7 seconds. And that'll come out for about 235 watts. Alright. And that's all we'll do for that one.